not, then I'll start sharing my screen. So today's session is on comparison of mean and median between two different populations. So what are the tests to compare mean and median? Till now, we did the descriptive statistics. Then we did the association, where we did like chi-square test of association. We learned chi-square test of two proportion or homogeneity. And then we did odds ratio and relative risk. The one test is left, that is the McNemer. Maybe we will try to do that in the last day along with the logistic regression. So today we will be doing the test to compare mean and median. So there are various options in this tests. So there is one option which is known as the one sample t-test. So it compares the mean to a standard reference. That's why it is called as a one sample t-test. I'll be telling you the commands and theory of this test, but there is no exercise for you people for one sample t-test. The second is the independent sample t-test, where we compare two means. So in the independent sample t-test, instead of one population, we take two population, and then its non-parametric counterpart is the Mann Whitney U. So Mann Whitney U, in this case, we compare to median. If the distribution is skewed, then we cannot go for the independent sample t-test, and then we opt for the Mann Whitney U test. Again, there is something known as the paired sample t-test, where we compare two related means. So these are the various options which we have under this comparison of mean or median. Again, the non-parametric counterpart of this paired t-test is the Wilcoxon sign rank test, where we compare the median of two related groups. So coming to one sample t-test, this one sample t-test, it is known as one sample because there is one group. There's no, like other independent and paired, you have got either two group or you have a measurement twice in the same group. But in one sample t-test, you have got only one group. Then how will you compare it? Because you will have only one mean. So in this case, you compare this mean of this one group as compared to some reference value. So you compare the mean value of a continuous scale with a known or a hypothesized. It can be a known or it can be a hypothesized value. So what are the research questions? So like if you want to know whether the new teaching method can improve the mean marks of students as compared to the institute mean marks, is the hemoglobin value of a sample population being studied, is it same as the national average? So in this case, you are taking a reference, which is a national value. I mean, that NFHS data probably you can take. Then you want to, if you want to see that is there any difference in the mean depression score between sample and population, then also you can apply this one sample t-test. So in all these, what have you observed? That there is one sample, and in that there is a one continuous variable or a scale variable, and you want to compare the average of mean value of this to the population average, and that population average can be known or it can be hypothesized. So appropriate statistical test for such type of research question is one sample t-test, also known as the single parameter t-test. Its other name is like single sample t-test, or other two names we have already talked, like single parameter t-test and one sample t-test. So what are the underlying assumptions? Because we talk that in all inferential statistics, we do the hypothesis testing. And in hypothesis testing, you will always have a null hypothesis and an alternate hypothesis. And you check your data also for some underlying assumptions. So now what are the underlying assumptions in case of a one sample t-test? So one sample t-test, the first assumption is that in this case, there is one dependent variable which is measured on a continuous scale. So the data is continuous, or it is a scale variable. Then second assumption is the variable should be approximately normally distributed. So here comes the role of either QQ plot or Shapiro-Wilk, because you have to test that data before you can apply your one sample t-test. But the assumption is it is not strictly normally distributed. We always write approximately normally distributed. Then the third assumption is there should not be significant number of outliers. So that we all have seen that we check that with the box plot. So outlier, we have discussed this. So I'm just skipping the part of the outlier, because in SPSS, you will have a normal outlier and an extreme outlier. But in case of JAMOVI, you will see that you have only got a value of an outlier. So the null hypothesis of a one sample t-test is the population mean, which we estimate from the sample, that is equal to the known population mean. And the alternate hypothesis is that the population mean, which we estimate from the sample, it is not equal to the known population mean. Now coming to the independent sample t-test. So first I'll tell the theory of all these three, and then I'll show you the command. And theory is also, it's very basic. So the independent sample t-test, the first word is independent. That means we the two samples which we take, those are independent of each other. That means that independence of observation, which we did yesterday, that assumptions will always be tested here. So there are two independent groups. Like if you want to categorize your population in male and female, or you want to categorize your population based on outcome, like people who died and people who survived. So these both two are independent group. So in that case, if you want to compare the mean value of a continuous or a scale variable across these two groups, then we apply the independent sample t-test. So what are the research questions? So like first research questions can be, if you want to compare the average BMI value of a population with history of CVD without history of CVD. So the two categorical variables are the one group is no history of cardiovascular disease, and then there is another group where there is a history of cardiovascular disease, and you want to compare the mean BMI. So mean BMI is what? It is a continuous variable, and you want to compare it across two categories. Similarly, the second research question could be, if you want to compare mean score of VAS, that is the visual analog scale or any other scale, pain score, and if you want to see the pain score between a group of people who have undergone surgical technique 1, and the second group is the group of people who have undergone surgical technique 2. So in that case, that mean pain score, that mean value, the difference of the mean value between these two populations, if you want to test whether it is significant or not, then you can use the independent sample t-test. The other type of research question can be, like if you are doing any study on medical undergraduates and you want to see whether there's a group of people, students who is having a good quality of sleep, maybe the more than 8 hours and the other is less than 8 hours. And you want to see that whether the mean marks obtained in the final professional exam, is it same in both the group or there is any difference? And if there is any difference, whether that difference is significant or not. then you can apply this independent sample t-test. So appropriate step in all these research questions, what have you observed? You have seen that there is a continuous or scale variable like mean marks, like BMI, like VAS score or the pain score. So all these are what? They are the scale variable. Or remember, on day one, we have learned regarding the nature of variable. So there is something known as the continuous variable. So these all three examples are the continuous variable, and we are studying it across the two categories of a nominal variable, like history of cardiovascular disease, without history of cardiovascular disease, surgical technique 1, surgical technique 2, or good quality of sleep, poor quality of sleep. So across two category of a nominal variable, if you are studying any continuous value, the mean score of that, you can apply this independent sample t-test. So independent sample t-test is also known as the student t-test, between subject t-test, because there are two different groups, and unpaired t-test, because we have got a paired t-test also where the assumptions are different. So there are three research designs which are possible if you are applying the independent sample t-test. So first is very simple, like we have discussed. There can be the mean difference between the two independent groups. In this case, you can see there is a male gender and there is a female gender, and you want to compare the mean cholesterol level. So here the two categories are the male and the female. These are the categorical variable, and the categorical variables is having only two categories. If the category is more than 2, then what is the test which we can apply? We have not done that, but still anyone who can type in the chat box?
ANOVA.
Yes. So Kavita is right. Anjana has also written. So it is ANOVA. Sinduri is also written. We'll do that on Monday. So if there are two categories, we will apply the independent sample t-test. So this is one type of research design. The second type of research design can be if you want to see the mean difference between two interventions, like in case of a randomized control trial. So in case of a randomized control trial, you have got two groups here. There is one group which is the intervention group, and there's a one group which is the control group. And you have given these two interventions, I mean the control and intervention, and after that intervention is the exercise training program. So after that exercise training program, you measure the cholesterol level after 6 weeks. And then you want to see whether after 6 weeks, is there any difference between the two interventions or not. So again, these two groups are two categories of a nominal variable. And this is a continuous variable. So our assumption is satisfied. So you can do that. Independent sample t-test. The third research design could be mean differences in the change score. So in the same example, which we have done, like if you have got the values of intervention group, so again, in this case, we are having one intervention group and we are having one control group, right? But before intervention also, you have got before intervention value of pre-cholesterol. That means before intervention, what is the value of cholesterol? And after your exercise therapy, what is the cholesterol? And this value is the difference between the two values. So if you want to see this difference, like after having your exercise training program, what is the difference in these pre and post cholesterol, and what is the mean change, mean values, difference in mean value. So if you want to see like which group reduced cholesterol the most, whether it was the intervention or control, so you have to measure the change score. So in the change score also, you can apply the independent sample t-test. So there are some underlying assumptions. So first assumption is there is one dependent variable which we measure on the continuous scale. We have learned that like in example of pain score or BMI or the mean marks. And the one independent variable that consists of two categories. And third is the independence of observation. That means there should be two separate groups. So in each case, if you can recall, if you have got a student who is having a good quality sleep and there's another group who is having a poor quality sleep. So both these two groups are separate. If you have counted one individual as a good quality of sleep, you will not count that individual in the poor quality. So individual will fall into only one category. That we mean by the independence of observation. The other assumption is that a dependent variable should be approximately normally distributed. So here also we have emphasized on the term approximately normally distributed. And again, there should be no significant outlier. So these two assumptions you will see in most of the difference in mean or median. Like in case of ANOVA also, these assumptions will be there. So in all the cases of the mean and median comparison, you need to check the box plot and you need to apply either the Shapiro-Wilk test if it is less than 50 sample. If it is more than 50, then QQ plot. There's another assumption which is known as the homogeneity of variance. So remember what we have done in the descriptive. We talked about the variances, isn't it? Variance we have shown you with the example that if there is a group mean and if you deduct that individual mean from the group mean and then you square it and then you add it. So we call that term as sum of squares. So that sum of squares, if you divide that by the sample size minus 1, that is your variance. And if you take a under root of that, that is your standard deviation. So remember, we have done that while we were talking about the descriptive statistics. So this variance, what this assumption says, it assumes that the two groups are coming from the same population. So that's why the assumption is that there should be homogeneity of variance. These variances should be homogeneous. And how do you test for? We'll see that. How do you test? It is tested objectively. There is an objective criteria which is known as the Levine's test, which value it gives. So this we have done. So concept of normality for independent sample t-test is, till now we have calculated the normality overall. But in case of an independent sample t-test, you need to check the normality across the two nominal category. But again, many times we say that it is a robust test. So even if it is nearly approximately distributed normally, you can apply this test. And there's again one rule that if you increase the sample size, then even the non-normal data starts behaving like a normal because of the central limit theorem. So even the non-normal data can be tested using the t-test. And then there is something known as, like, if the distribution, even if it is skewed, but if the distribution of both the group is in the same direction, like both the group, either the positive skew or negative skew, then also you can apply this independent sample t-test. So how we calculate this homogeneity of variance in Jamovi? So it says that variances in both the population from where the samples have been selected should be equal. So we have got the Levine's test for equality of variance, and this Levine test tests whether the two samples, they have come from the same population with the same variance. So Jamovi gives two types of independent t-statistic. And this Levine's test is also like Shapiro-Wilk test. We want its p-value to be more than 0.05 because the null hypothesis says that it is of equal variance. So that's why we want that p-value to be more than 0.05. So this Levine test of equality of variance test regarding the homogeneity of variance. So based on that, Jamovi gives two types of independent t-statistics. if there is an equal variance, that means if the p-value of Lemine statistics is more than 0.05, then you report the standard t-value, its degree of freedom, and p-value. And if it is of unequal variance, then you report Welch t statistics, its degree of freedom, and p-value. So how we decide for that? You see the p-value of Lemine statistics. If it is more than 0.05, that means there is a homogeneity of variance. In that case, you use the standard independent sample t-test. If the homogeneity of variance is not met, that means if there are unequal variance, then you report the Welch t statistics, its degree of freedom, and its p-value. So what is the null hypothesis? The null hypothesis states that the population mean of the two groups are equal, and the alternate hypothesis states that the population means of two groups are not equal. So now so this is regarding the parametric one, if there is a normal distribution. If the distribution is not normal, then what will we do? We will go for this Mann Whitney U test. So what is this Mann Whitney U? So same, if the data is not normally distributed. So if you want to compare the mean value of outcome X across two categories of a dichotomous variable, like comparison of mean SGOT of alcoholic liver disease and non-alcoholic liver disease patient. But when you have put this QQ plot, you have seen that it is not normally distributed. So what will you do? You cannot do independent sample t-test if the sample size is not that good. So in this case, you should go for the Mann Whitney U test. So Mann Whitney U is preferred when you already know that the variable of interest does not follow the normal distribution as reported from the previous literature, or you before had planned to compare the median of a variable of interest across the categories of a nominal variable. So this Mann Whitney U test, it is used when the assumptions of t-tests are not met, and it is a non-parametric test. It arranges the sample data in a rank order. So like if there are very deviant values in your data set, it gives rank to each data, and then it compares the mean rank of the continuous variable. So the research question could be, it is the same research question, but I have just replaced the term median with the mean. So if is the median SGOT level of population with alcoholic and non-alcoholic fatty liver disease are same? Is median post-operative pain as measured by the visual analog scale is similar for surgical technique 1 and surgical technique 2? Or is median Apgar score of babies born through normal vaginal delivery and cesarean section is same? So in all these cases, what have you observed? That there is a scale variable in each question, and we want to compare the median of this scale variable across two categories of a nominal variable. So the appropriate statistical test is the Mann Whitney U, also known as the Mann Whitney test. So the assumptions are again like dependent variable should be measured either on an ordinal or a continuous scale. Like in this case, you can use the Likert data also, because remember we have studied that in the ordinal scale, if the number of categories are like more than 5, you can treat it like a continuous. The second one is independent variable should have only 2 categories, like maybe gender or interventions. There should be no relationship between the two groups or within each group. That is the term which we mean by the independence of observation. And then the dependent variable should not be normally distributed across 2 categories of a independent variable. And the distribution should follow the same shape, both right skew or left skew. So this case, you can see here both these SGOT across the MI order, you can see these are not normally distributed. So hypothesis is that the median of the two groups are equal. null hypothesis, and the alternate hypothesis is that the median of the two groups are not equal. So now we'll go to the question. So this is the question number 1. I have to first compare these parameter across smoking status, the SpO2, cortisol, LDH, and ferritin. So let me write it because otherwise I will move some other variable. SpO2, cortisol, LDH, and ferritin. And then I have to compare the mean values of SpO2. So let's start with this. So first you should know how to compare because it's an independent sample t-test. So if you have to measure the mean value across two categories, you will similarly check the box plot and QQ plot across category. So in this case, like if mean SpO2 at the time of admission across smoking status. So I will open my Jamovi and maybe I'll move this back. So how to go about it? So till now, we have learned regarding, this is the data set. And if you click on this analysis, we have done till yet the exploration. So we did this exploration in the descriptive. And yesterday we have used this option of frequencies for the chi-square test. So today we'll use this option, t-test. So Priyanka is writing, if Likert scale is 5, can we consider it as continuous? Generally, if you see the literature, it says that 7 or more. But we have seen many articles, they consider even the 5-point Likert scale as a continuous scale. But we have referred to some standard textbook and articles, and generally they say that it should be ideally 7 or more than 7. Okay, Dr. Priyanka. Okay, so this, I will just delete all this, remove. So now this is the data, and I'll go to this analysis. In the analysis, I'll click on this option of, so in the t-test, you can see there is an independent t-test, there is a paired sample t-test, and there is a one sample t-test. So first I'll tell you regarding independent sample t-test, then briefly I'll demonstrate this one sample t-test also. So if you click this independent sample t-test, you will see that there is a dependent variable box and then there is a grouping variable. And then right now we'll focus on various options. So you can see here in the assumption check, you have this assumption right here. So we have done this assumption section, and all those assumption check, you have to first check these assumptions. Okay. Because on the basis of that, you will click here, whether it is whether you will click Mann Whitney U, because by default, this student is clicked. But you have to see if the homogeneity of variance is not met, then you have to click this Welch T statistics. And if the normality is not met, then you have to click this Mann Whitney. So before you go for any other test, you have to do the assumption checks. So I will first do the assumption check. So what was the question? SpO2 level at the time of admission. So this is the SpO2 one. I have moved this to dependent variable. And you can see here, there is a sign of scale. Can you see this? There is a small sign of scale here. So this shows that you should transfer only a scale variable to this dependent variable, because that is also one assumption, that the dependent variable should be a scale variable. And then this is a grouping variable. So grouping variable can be a nominal or ordinal. And you can see the sign. If the sign is like this, three petal flower, then it is a nominal. And if the sign is like this, stacked bar with increasing height, then it is a ordinal. So you have to transfer variable according to these sign. So I will transfer this across. I have to see it across. Let me see the question. Across smoking status, I guess. Yes, across smoking status. So I'll transfer this smoking smoker here. You can uncheck that and you can first do these three assumptions. So normality, I am not clicking, but you can check the Shapiro-Wilk value, but ideally it's the QQ plot which will be tested. But there is one, so you have to wait a little bit because it is buffering. So you can see here, it gives you the overall QQ plot. And then if you click in this box, you will not see, yes, I'm repeating. In this box, ideally, if you go by the theory, this gives you overall normality test. That is the QQ plot. But we have to check it across the group. So that's why, remember in descriptive, we have told you how to make a categorical, like a split QQ plot. And I will show that again. So what I'll do, I will uncheck this because Dr. Soma wants this again. So I'll move this back to the windows. So you can check here. This is a dependent variable. So dependent variable is a scale variable, and for my demonstration, the dependent variable is SpO2. So I will move this SpO2 to this dependent variable, and this grouping variable is a smoker. So I will move this smoker to this grouping variable, and then I will check for the assumption check. So I will first check with the homogeneity. So if you see the homogeneity, what is the p-value of this homogeneity? Yes. Can anyone tell, like, is the assumption of homogeneity of variance met or not met? Please type in the chat box. Priyanka is writing not met. Deep is writing not. Shruti is writing not met. Not met. Why it is not met? Yes. Soma is writing met. Soma, how can you say that it is met? Can you unmute and answer here? How you think that this is met here? Less than 1. Okay, Venkata, it is not less than 1. Yes, Seethal is right. Anjana is right. Okay. So you should remember the cutoff value is 0.05. That is the p-value. Yes, Manoj is also right. When the p-value is significant, then this assumption is not met because it's a significant Levine's value. So if the assumption is not met, then among these options, what should I check? These are the three options: student, Welsh, and Mann Whitney. Welsh, right. Very true. So I will not report the typical student value. I will take the Welsh T. Now, if I have to click this Welsh, then whether I should go for Welsh or Mann Whitney, that I'll see with the normality. But there is a problem in the Jamovi. One problem is that outlier you cannot check here. Box plot, you will have to go to descriptive. So ideal way, many times we do it, but I am just telling you the ideal way of doing it. So ideal way will be, you have to go to exploration, open descriptive. In descriptive, you put this variable SpO2, which is the continuous, and in categorical, you put the smoker status, smoker, and then I will uncheck all this because I don't want any of these mean median now. I only want this box plot and this QQ plot. So I will go to these plots and I will click this box plot and I will click this QQ plot. Then this gives you the distribution across the category, because we have to check the distribution across the category. So if you see these box plot, you can see
morning
that
okay, now 10 to 12:30. At least you are doing something. And the laptop. Okay.
you can mute.
Actually, technology.
So you can see here that this is a box plot, and there is a no outlier in each of the category, neither in no smoker, neither in the smoker. Then coming to the QQ plot. So QQ plot, you can see that it is across the category. Like this is in the no smoker, and this is with the smoker. This is with the no smoker, and this QQ plot is with the smoker. So you can see that it is approximately normally distributed across these diagonal line. And if you are like a little confused, then again you be told that you can go with this histogram with the density plot. It will also show you the distribution. So now you can take, this is a little, you can say that in yes, it is not exactly, but approximately normally distributed up to you. But again, there was one rider. Remember, if there is enough sample size, and if you go by the central limit theorem, still you can take a call to use this independent sample t-test. Then again, the next thing, if I can see, so these assumption, I have seen that there is no significant number of outliers, and then I can go to this t-test, independent sample t-test. So if you click this again, this window will appear. So now I have test for the assumption of normality, and this you have to write. So this I will click this probably. In this case, maybe there is some connectivity issue. Is it okay now? So now I will go for these values. Is it okay now? Again, see the zoom. Unstable it is. Am I audible now?
Yes, ma'am.
Okay, yes, sorry. There was some, okay. So now I hope I'm audible, and no, it's still lag. So what to do for that?
वीडियो स्विच ऑफ करके ट्राई कर सकते हैं.
So I'll off the video probably, yes. So is it okay now? Still the same problem? Still lagging. Okay, I will try to repeat. Okay, better. Khushbu is writing better. Okay, okay. Now Rajan is also okay. So okay. Then you can see here that now I will click this mean difference, because I'm sure that all my assumptions are met. You can click this 5% confidence interval of the mean difference, and you can click on this effect size. Remember, we talked about the effect size yesterday. So in case independent sample t-test, it gives you the effect size form of Cohen's d. So Cohen has like coined this term, not term, like he has also explained the effect size, and the value is same which we did yesterday, like 0.3, 0.1, 0.3, and 0.5. So that Cohen's d, if you see the value, you will see it, what is the value, and you have to report the this effect size also. And then descriptives, because you want descriptives also, that is the mean value. And if you want any plot of descriptive, you can click. Still lagging or any problem? Still 2 seconds lag. So you can see here, Can you all see my screen now?
Yes, ma'am.
Okay. Is it better? Like the quality
Yes,
of
ma'am.
audio and lagging issue?
No, ma'am, it's better now.
Okay. Thank you, Neha. So we were talking regarding how to interpret and Cohen size. Cohen, that is the effect size. So Cohen has also explained this effect size, and the value of this effect size tells you whether it is a moderate effect size or a mild effect size or a very good effect size. So if you see, this is just to see the interpretation, this is the T statistics, this is the degree of freedom, and this is the Welch T statistics. So you have to write that in your interpretation. And this is the p-value. So this says that the difference between the SpO2 between the two group, that is a smoker and non-smoker, that is 2.86. The standard error of difference is this. And if you see the 95% of confidence interval, then you can see here. And this is the effect size. So effect size is 0.579. That means it is a good effect size. And you have to report that also. Homogeneity of variance we have discussed. If you see the descriptive, you have to report the descriptive also. So if you see the mean value of SpO2 in non-smoker is 95.2 and in smoker it is 92.3. So the mean SpO2 is less in smoker, and that's why you can see here the difference was 2.86. So this difference is the difference of 95.2, and then we have got the 92.3. So there is nothing known as the normal effect size. We always classify effect size into the very minimal, moderate, or very good effect size. So yesterday we did like up till 0.1, 0.3, and 0.5. That we generally 0.5 or more than 0.5, we call it as a good effect size. So it is a good effect size if it is more than 0.5. So then we come down, and this is the plot. So you can see here that this is the plot for smoker, and this is for the non-smoker, median and 95%. You can see that this square, this is the median, and this dot circle is the mean, and this is the 95% CI along with mean. So this is the descriptive plot. So this is the independent sample t-test. Then how to write the interpretation. So interpretation, you will make a table like this, and then you can write here that there were number of smokers. So there were 123 cases of smoker and 153 non-smoker and 57 of smoker. And then the mean. So mean, I have written here the dependent variable. You can write here, every time I change, but I think I don't save, that's why. So the mean SpO2 level. I will write the mean SpO2 level across levels of smokers and non-smokers. Smokers and non-smokers were normally distributed as reported by the visual inspection of the QQ plot to test for normality. And there was no outlier. So in this case, we saw that there were no outlier. So there was, I'm just modifying a little mistake here. So there was no outlier as evident by the visual inspection of box plot. So I have written the assumptions also, the two assumptions, and then I have written that the independent sample t-test was run to determine if there is any difference in the mean SpO2 level, between the levels of that smoker and non-smoker, and there was a homogeneity of variance. So there was homogeneity of variance, it was not there. So I will write there was no homogeneity of variance as assessed by the Lemoine's test of equality of variance. And then I have to write the p-value for that. And then I will write, so we can, you only have to write the p-value of the Lemoine's test of equality of variance. So maybe if the p-value, if it is not, then you can write that the p-value was less than 0.05. And then we observed a statistically significant difference, because in this case, we have observed that there was a significant difference in the mean SpO2 level of patients having the of the smokers. I will write smokers versus non-smokers. And then you can give the mean and standard deviation of each of these two, which is here, like this value. In this case, you can write 95.2 plus minus 97 and 92.3 plus minus, sorry, not 97, this 5.89 and 3.75. This was the median. So this is the write-up of an independent sample t-test. It has got and then you can write the p-value here, the Welch t statistics, which we have ticked. So this is how you write the write-up. So is it clear to all of you? How do we do the assumption testing? How do we write those assumptions in our result? How do we make table? And how to write interpretation? Any issues with this independent sample t-test? Or Priyanka is writing, how do you have to check Yes, you can. It's up to you. If you check, it's better because it will give you the confidence interval of the effect size also. So maybe I will check that. So you can report the confidence interval because it will tell. So you can see the upper and lower. But I think it is not coming, this effect size. Upper and lower, but many times it comes also. I don't know why it is not coming here. You can click that. Apart from this, any other issue with this independent sample test?
Ma'am, here Ligan's significant, so variance is there. So we'll report the mean value or the median value here.
No, you have to report the mean. Median you will only do when, by default, median also comes here. If you see this, median is also there. You can, this median we will report when you will click this Mann Whitney U test. Otherwise, mean plus minus standard deviation. Yes, we will share, Dr. Priyanka. In fact, there was some delay from our end in writing the interpretation of the first 2 days. So we will share the template of all the write-up, including logistic, ANOVA, everything. But definitely by the end of this workshop, you will get it. Don't worry. No, in that case, it's better. You have to report mean. But by default, this median is also there. If you report both, that's also okay. But preferable is mean, because mean makes more sense. Because median is, again, you know that it is less meaningful as compared to a mean value. Okay. Any other query? Anyone wants the commands to be repeated or any other concepts to be repeated before I tell you the Mann Whitney U? Because Mann Whitney U is also very much similar to this, except that, in that we tell the median values. So if not, then I will go to the question of the Mann Whitney U, and probably there you can see that it is generally the SGOT. So if you see the question, so compare the median LDH at the time of admission across smoking status, because through descriptive, remember yesterday, day 1, we did the descriptive statistics. So in descriptive, you have to check the normality of all continuous variable and box plot also. So by descriptive, you have a fair idea, like which are the variables which are normally distributed in your case and which are the skewed one. And then you can apply, if you want to test that mean or a median value across 2 groups, then you can use Mann Whitney U or independent sample t-test, depending on this concept of whether the normality assumption is met or not met. So now I will go to this. So I have to see the median LDH. So in Jamovi, I'll again go to this exploration, because I have to check with so this exploration, if you can come here also, which was already, this was open. So in this smoker, instead of that, I will transfer the LDH. So this is the LDH. And I need the box plot. So this is the LDH, the 2 graph across non-smoker. This you can see, these are the outliers. And this you can see that this is not normal. So in this case, you can see that one seems to be normally distributed and the other is not normally distributed. In that case also, you can take a call and you can go for an independent sample t-test also if your sample is large enough. So, but because I have to demonstrate independent sample, the Mann Whitney U, so this I have tested the assumption. And one more assumption, that assumption comes after this, when you apply the statistics. So I will again go back here And in this case, instead of this SpO2, I'll move this LDH. So this LDH will be moved here. And then you have to click on Mann Whitney U. So if you see the Mann Whitney U, so the value of Mann Whitney U is this 3482, and it is the p-value is not significant. And if you see the difference also, mean difference, although the difference is of 3, so 925, so no, and 977. But if the difference is how come this difference is coming 3? So mean is 925 and 977, and median is 866 and 848. So let me LDH. And then in the effect size, it takes the rank by serial correlation. It is not the Cohen's d, but the rank by serial. So if it is not significant, we have learned yesterday that we will not go for this reporting effect size. So then you can uncheck that. And Madhuri is asking one question, is there any criteria like number of outliers to tell whether it is normally distributed or not, like the number based on the outlier? So generally, it is like percentages. I don't want to quote that, but if it is 5 to 10% of outlier, then you can take a call. Again, I said that it's better that you do the analysis, including the outliers and excluding the outliers. So you can, if the outliers is not very high, like it is 5 or 10, you can do the independent sample t-test after excluding the outlier. And you can again do the testing, including the outlier, and then see the difference. And then you can write in the write-up that you have removed the outlier and then done the analysis. One idea is this. If the outliers are genuinely high value, like I have discussed with you, one case where the researcher was saying that, no, I have to include the outlier because that is an unusual high value. So in that case, you can include that outlier. And again, then if the sample size is high, even with few outliers, you can go with the independent sample t-test. It is up to the researcher what he wants to show, median or mean, or, by the Mann Whitney U or the independent sample t-test. So I'm not sure, I don't know this rank, but they don't give the rank here. Actually, this is the problem with Jamovi, that the difference which it gives here, this is not the mean difference, rather it is the rank difference. But here in the descriptive, they don't give the rank, rather they give the mean and median. So don't get confused with, because in SPSS, they compare the mean rank. Okay. So that's why I told that initially you learn one software, and if you have a command on one software, then interchangeably you can use the other options in other software also. So this mean difference is of mean rank difference, whereas this value, if you see, this is the mean value. So you can just write that in the interpretation. And this is the plot, and this normality we have checked. So this is how you see the, what we can say, this Mann Whitney U. So if it is clear, can we go to the breakout room for